So a long time ago, they thought that the universe was static, uniform, and infinite. And basically, this is what they thought about before the 20th century. It's only really the work of Hubble that kind of really got around this idea. And it kind of had to be, really, if they looked at Newton's laws. Basically, if the universe had a certain size and it had a load of mass within it, then, Newton's law of gravitation says that at some point the universe must collapse. And obviously, the universe hadn't collapsed. And if the universe was, when they looked at it, it seemed to have always been there, that meant the only way that you couldn't have had all the mass in the middle pulling everything in was if mass was everywhere and it went on for an infinite distance. But there was a problem with this theory, and this was pointed out by a guy called Olber. And what we now have is something called Olbers Paradox. If the universe really was infinitely big, and it was uniform, and it was static, then whichever way you looked, eventually, no matter where you were in the universe, you'd see a star. And for that reason, the night sky ought to be really bright rather than being black. It's a bit like being in a forest. So here I have my forest of trees, and if we have Maid Marian in the middle, whichever way she looks, eventually she's going to see a tree. And you might notice this. If you're in the middle of a deep dark forest, you don't see the sky at the sides. What you just see is more and more trees. Effectively, everywhere you look, eventually a tree is going to be there. And in the model that they had of the universe, which was infinite, then effectively whichever way you looked, eventually you'd see a star. Now, one of the problems with Olbers Paradox basically is that as you go further and further away from the Earth, the light from each star is going to be dimmer and dimmer. But let's imagine that we have a load of shells around the Earth, each having kind of a uniformly distributed amount of stars within it. Well, if we think about a shell that's a distance of r away, it might have n stars within it. If you go to a shell which is twice as far away, which is 2r, because we then think about the surface area of the sphere, there are then going to be 4n stars within that shell. And if we think about a shell which is 3r, a radius of 3r away, this would then have 9n stars within it. So as we go further and further away from the Earth, there's more stars which are shining down on the Earth. However, if they're further and further away, the amount of energy that they're radiating, which obviously is emitted in 360 degrees in like this kind of sort of sphere, then there's this kind of 1 over r squared relationship. So effectively we can think about the intensity of this being equal to 1 over r squared, and the intensity from each star is going to be maybe a value of 1. If these stars here are 2r away, then the intensity of each star is a quarter, but there's still 4n stars, and so the total intensity is going to be a value of 1. Again, over here, the intensity is going to be equal to a ninth from each star, but there's 9 times as many stars, and therefore you still have the intensity there. And effectively what we're saying is that even though stars might be a long way away, and the starlight from an individual star is quite dull, there's a lot more stars as we go further and further away from the Earth. But this still means that if you have this infinite, static and uniform Earth, then the night sky shouldn't be dark, but it should be basically as bright as our sun. But it's not, we know that, otherwise we wouldn't be able to see the other stars in the first place. We wouldn't have it being dark at night. So how can we solve Olbers Paradox? Well, we can basically solve Olbers Paradox by thinking about what we actually sort of know today. First of all, it's not an infinite universe. There is an edge to the observable universe. The second thing is it's not static. The universe is moving and moving further away. That means the starlight for maybe distant stars is redshifted out of the visible part of the spectrum. And also, stars do have a certain lifetime. They don't exist for an infinitely long amount of time. They come into being, they go through their life cycle, and then at the end of it, they become a white dwarf or they supernova. So basically, Olbers Paradox, they couldn't solve it at the time with what they knew, but what we now know about an expanding universe means that it isn't actually bright at night.